Okay, let's switch gears now. So for these problems, notice all of our variables are trapped inside of a logarithm. And all of them are also related because we'll be able to get into this format. If b is greater than 0, b not equal to 1, log base b of m equals log base b of n, if and only if m equals n. So this is another one-to-one property, but this time this is for logarithms. We typically are going to go in this direction just like you did before for exponential. And what this says is if you get log equals log, then you can just set the arguments to be equal. Couple comments. One, notice it's only one log on the left and one log on the right. Two, they have to be the same base. And for this class and also college algebra, they're going to be the same base. They're going to be rigged like that. And three, m will then equal n. Oh, I forgot to say something here. M is positive, n is positive. We need that part too because after we solve for the variable, we have to make sure that it makes your arguments positive. If it does not make it positive, then it's not a solution. We'll need that come on up here in a second. So in part A, notice we're all set for operation here because we have log equals log. The coefficients of both the logs are 1, and it's the same base of 7. So according to the one-to-one property right here, we can set the argument on the left equal to the argument on the right. So if I bring this over by addition, bring this over by subtraction, notice I get x to be 11. Now we have to ask ourselves, if I put 11 in for the x in the original problem, do I get a positive argument? And I do. So 11 is our solution. So to use this property again, you must have log equals log. And if you can do that, then you just set the arguments to be equal. So in part B, notice we don't have log equals log, because how many logs are there on the left-hand side? There's 2. So we need to get it into one logarithm. Notice we are subtracting logs there. If we're subtracting logs, how do we write it as one log? What rule do we use? We use the quotient rule. So the left-hand side is the natural log of x plus 1 over x minus 2. Remember the quotient rule says if you're subtracting logarithms, it's the log of the numerator. It's the log of the argument of the first it's the log where the numerator is the first argument and the denominator is the second argument. That's better. Well, now we have it all set for our one-to-one property because we have log equals log, and they're both the same type of log. They're both natural logs. So then we're going to set the equations to be, the arguments to be equal. This is a rational equation. To solve a rational equation, we're going to multiply both sides by the LCD, in this case x minus 2. On the left, we get x plus 1. On the right, we get 3x minus 6. Bringing the 6 over, bringing the x over, we get 2x equals 7. And that implies x equals 7 halves. Now ask yourself, does 7 halves make any of the arguments negative or 0? Nope. 7 halves plus 1 is a positive number. 7 halves minus 2 is still a positive number. 3 is always positive. So 7 halves is a-okay. We don't have to worry about anything else. In part C, notice on the left-hand side we're adding logs. If you're adding logs, what rule do you use to combine them? Hopefully you said your product rule. So if you're adding logs, you multiply their arguments. So we'll do x plus 1 times x. Distributing an x through, we get x squared plus x. The right-hand side we're going to leave alone. We're all set for our one-to-one property because we have log equals log. So we're going to set the arguments to be equal. Bringing everything to the left-hand side, we get x squared plus 4x minus 5 equals 0. How does x squared minus 4x minus 5, plus 4x minus 5 factor? X plus 5, x minus 1. Setting each factor to 0, this would give us negative 5. This gives us positive 1. Okay, let's check it. If I put negative 5 into the original arguments, notice the ones on the left are negative. You can't have a negative argument. So negative 5 is bad. All it takes is for 1 to fail. Notice on the right-hand side, negative 5 would have been A-OK. However, since it failed on both of these, again, all it takes is 1. We stop and say that guy's not a solution. But how about x equals 1? If I plug in 1 here, I get 2. Here I get 1. Here I get 2. That's okay. So x equals 1 is your only solution. So in all three of these, we were able to use the one-to-one property. These are all logarithmic equations because the variable is trapped inside of a log. But we were able to write log equals log. In that case, you set the arguments to be equal.